Day 27. Predict employee attrition using XGBoost. In this particular project, we will build a predictive model using XGBoost to determine whether an employee is likely to leave a company based on various job-related features such as job satisfaction, years at the company, salary, and performance ratings. So let's get started. First, I'm going to install some of the required libraries including XGBoost, Pandas, scikit-learn, matplotlib, seaborn. Some of them you probably already have installed. I have all of them installed, so it's going to take a couple of seconds to run through this, so that's good. Next step, let's look at my files. I have the attrition CSV file, which I actually downloaded from Kaggle. This is IBM HR Analytics Employee Attrition Performance. You can download from Kaggle any of the attrition. If you look for employee attrition, you'll find a lot of different data sets that are available in Kaggle. You can use whichever you like, but make sure that the columns match or you fix the columns accordingly. And to run that, I have created a project here called test.py. Right now, it's inside my day 27 folder. Let me check, make sure your day 27 folder, and it's called test.py. So I'm going to start writing my code inside here. So first step is to import the libraries. The different libraries that I would need is first is pandas and numpy. These are data manipulation and numerical operations. XGBoost, this implements the XGBoost classifier which we'll be using in our code. Next we have sklearn modules for pre-processing, model evaluation, and performance metrics. We are getting sklearn.model selection, import train test split. For sklearn pre-processing, we are importing the label encoder, and from sklearn metrics, we are importing accuracy score, confusion metrics, and classification report. Next, from matplotlib, pyplot as plot, we're importing that. That is used for data visualization, and also we need seaborn as SNS. So these are just for data visualization. Next, let's go ahead and load the data set and replace this with your actual file path, whatever you have. I am in my same directory, and I'm going to read that CSV as attrition.csv file. Next, let's display some of the first few rows. So I'm going to say print dataset preview df.head. So this will display the first few rows of the data set, so we can see how the data looks like. Now let's go ahead and do some data pre-processing. Here I'm gonna first drop the irrelevant columns by calling df.drop, and I'm gonna drop employee number, over 18, standard hours on the axis of 1, and in place equal to true. So I'm going to keep them in the particular data frame. So this removes all the irrelevant columns that don't affect attrition prediction. Next, I'm going to go ahead and encode the categorical variables by calling label encoder equal to label encoder. For column in df.select on my data frame, select data types, include objects. I am going to go ahead and encode them by calling the label underscore encoder fit transform df column. This encodes the categorical features into numerical values using label encoder, which is helpful for making sure it doesn't give us error, because the classifier doesn't understand categorical values, it understands numerical values. So that's why we do this. Next, I'm going to go ahead and split the features and target using our same train test split function. So for that, first I'm going to get my x, which is df.drop, and I'll drop the attrition because that is my feature. So I'm going to say y equal to df attrition. So x contains all the features except the target, which is attrition. So again, sorry, I said attrition is feature, no, it's a target. And that target I'm going to use in y variable, the target variable, where 1 equal to left and 0 is equal to the employee stayed. So 1 left meaning not left side, but the employee left, whereas 0 is he stayed with the company. Now let's go ahead and do the train test split. So x train, x test, y train, y test, train test split, x comma y, test size equal to 0.2, random state 45, stratify equal to y. This splits the data into training and testing sets, 20%, 80%, 20% for testing and 80% for training, and it preserves the class balance by saying stratify equal to y. Next, I'm going to go ahead, create and train the XGBoost classifier. To do that, I'm going to say model equal to XGB dot XGB classifier, use label encoder equal to false, evaluate metrics equal to log loss. This initializes the XGBoost classifier and trains it on the training set. The use label encoder equal to false disables the deprecated label encoder. Next, we are going to fit our model and pass it the data X train and Y train to train the model. Next, let's go ahead and make some predictions. So I'm going to go ahead and move it up, and let's make some predictions here. Y pred equal to model predict X test. This uses the trained model to make predictions on the test set. And then finally, let's go ahead and evaluate the model. Now to evaluate the model, we have three different things. One is accuracy score. We pass it Y test Y pred. This calculates the overall accuracy. Next, confusion matrix, Y test Y pred. This generates a confusion matrix which we will be displaying using matplotlib. And then we have the classification report. This provides precision recall, F1 score, and support in a tabular format. So now that we have that, let's go ahead and display our results. First, I'm going to say model accuracy is accuracy 100 times 100.2f. This will give me the percentage. Next, classification report. I'll display the classification report and the confusion matrix displayed here. So this displays all the evaluation metrics for us to see on the command prompt. Next, let's go ahead and visualize the confusion matrix. So I'm going to say plot.figsize 8 by 6. So that will create me an image of 8 by 6. sns.heatmap confusion matrix. I'll pass that values. Annotate equal to true. Format equal to D. CMap equal to, we'll use blue colors. Xtick equal to state and left. Those are my X tickers and Y tickers. I'm going to use left, state and left on the other side. So it will give me my true positives, true negatives, false positives, false negatives. Now let's go ahead and give a title, confusion matrix. Y label I'll say actual, and X label I'll say predicted, and show the graph. So this entire code here will visualize the confusion matrix using Seaborn for better readability than what we have in our text. So let's go ahead, save this file, go to our command prompt, and I'm going to say clear this out, and I'll say python test.py, and it's going to run. As you can see here, we have our data set first. It will give me the preview of all the different columns. Of course, we have a lot of columns, 35 columns out there. Gave me a little bit warning, even though I've set use label encoder to false, but still it gave me model accuracy 86.73% based on the data that we have. Our classification report, which shows the precision, recall, F1 score, support, all data displayed here for accuracy, macro average, and weighted average. Finally, our confusion matrix here, which is displayed using our matplotlib and Seaborn. We display that data here where it shows state versus left, true positives, true negatives, false positive, false negative in this confusion matrix here. So I hope you are able to follow along and get this working. If you had any errors or issues, let me know and I can get back to you. Or if you have any other questions, let me know in the messages and I'll get back to you.